Hello everybody, today we have another fantastically interesting video on trigonometry, particularly inverse of sine, cosine, tangent. So I'll review a little bit as always. The Pythagorean theorem is used when we are given three sides of a triangle, correct? So we have one side, one side, one side here. Anytime you have three sides, we always use Pythagorean theorem, not sine, cosine, or tangent. So we remember that the one across is always going to be your C, this is going to be your A, this is going to be your B. And so we do A squared plus B squared equals C squared, and then you guys know the rest of this. Plus 100 equals C squared. We get 676, square root both sides, and we get 26 meters equals C. No problem. Pythagorean theorem is when you have three sides. And this seems very trivial, not important, but it is important to see when we have three sides, it's Pythagorean theorem. So now, when we have two sides and one angle, like this problem, right? This is the same problem. We have two sides, but now we have an angle here. Whenever we have an angle involved, that's when we switch to sine, cosine, and tangent. Very, very important. Okay, because a lot of times you'll be like, wait, what do I use? Remember, when you have an angle, sine, cosine, tangent now. And so let's go ahead and label these sides. We think, what are the sides in relation to this? Well, this one right here, this is going to be the opposite side, correct? So this is the opposite, right? Adjacent means next to, so this one is next to it, so this is going to be your adjacent. And then this, the one across, is always going to be your hypotenuse. And so we have to think, all right, we have SOHCAHTOA, sine, right, that's sine, cosine, tangent, SOHCAHTOA. We are using the adjacent and the hypotenuse, so the A and H, so that means we will be using the cosine. So we have the cosine of the angle, 67.38, equals the adjacent over the hypotenuse, adjacent 10 over the hypotenuse, which we can put as x. And now we solve for that x, and so we multiply both sides by x. I'll go through this fairly quickly. These go away, so we get x times cosine of this equals 10, and now we divide both sides by the cosine of 67.38. Divide the 10 by 67, the cosine, sorry, I'm awkward, of 67.38. These go away, and we get 10 over the cosine of 67.38. We put that into the calculator, and make sure when you put this in the calculator that your calculator or Google calculator, this is set to degrees, okay, not radians, degrees. And so that gives us, x would be 26 meters, right? So that is 26 meters. And so far, those are the two problems. We have to see what is a little different about this problem, okay? We have two sides and we have an angle, so we know we're going to use trigonometry, right? But for this problem, what's a little different is we're missing an angle, right? So we're not missing a side this time, we're actually missing the angle. So this is going to be a little different, okay? So the main question teller for this video is, how do we get the missing angle, okay? And so what we have to do in order to get that missing angle, we have to use what's called inverse of sine, cosine, tangent to find the angle measure. It's going to be the same setup, same process, just one little thing added to it, but we have to find the inverse sine, cosine, tangent. But it doesn't change the fact that since we have an angle involved, we are going to be using these, not Pythagorean theorem. And so what do we do? Okay, so step one, we decide if we're using Pythagorean theorem or sine, cosine, tangent. Since the angle's involved, we're using sine, cosine, tangent. We set up sine, cosine, tangent as normal, and then we'll apply the inverse. Okay, so let's see which one we are going to use. Well, if this side is right here, this is going to be the one next to it. So let's label them. This is adjacent. The one across, this is going to be the opposite, and this is always the hypotenuse. So if we're trying to decide which one, we remember SOHCAHTOA, SOHCAHTOA. We are using the opposite, and we are using the hypotenuse, right? This one isn't given to us, so we're not going to use adjacent. So we have O and H, that's going to be sine. So we set this up as normal. Sine of the angle, right? It's always sine of the angle. So remember, the angle instead of x, we can put theta. Okay, that's just the x for angles. And then we have the opposite over hypotenuse, O over H, 10 over 26. Okay, and some people don't like fractions. If you're scared of fractions, you can put that in the calculator, or you can have sine of theta. When you do 10 over 26 in the calculator, you do get 0.38, right? So 10 over 26, you don't like fractions, put it at 0.38, that's fine. Okay, so this is the next step, right? We have to get the theta by itself, but we cannot divide both sides by the sign, right? That's like dividing both sides by the word radical, right? We can't divide both sides by a word, right? We have to do some sort of opposite, okay? And so we know the opposite of multiplication is division, the opposite of addition is subtraction. So the opposite of signing this is going to be the inverse sign. So this is how we write it. Okay, so we write the sign, and then we write a little -1 right here. This means inverse. Okay, so this is the opposite. And when you do the opposite, what's really important is that these switch spots. So you're actually going to inverse sign the 10 over the 26, and you make that equal to the theta. Because now that we've done this opposite, the theta is by itself. Okay, and so we can do that same thing right here. We'll do the opposite of this. We have to take the inverse sign, and now we switch these. So we get the inverse sign of the 0.38, which equals theta. So now, once we do that, that one little switch, we can just put this in your calculator, right? Or the Google calculator, that's fine. Okay, and so when we go ahead and put this, we get 22.62. So all this becomes 22.62 degrees, which is theta. So that is your angle measure, 22.62 degrees. There we go. So this is just the one new step. That's all we're doing. Okay, and so how do we put that in the calculator? Some calculators have this. If you look at our graphing calculators from school, which you guys don't have, it has this notation, right? But if you're using the Google calculator, it doesn't recognize this, okay? So if it has this, go ahead and put that in the calculator just like this, but sometimes it won't. So you can put it in the calculator just like this sign, 10 over 26, or, okay, another way to write this, the inverse sign, this represents inverse sign, is arc sign of 10 over 26, right? Either of these ones should give you the correct answer, right? So this is arc sign. Arc sign means inverse sign. If it were up to me, I would change this to INV sign, right? Wouldn't that make more sense? Inverse sign instead of arc sign, but whatever, I don't make the rules. Inverse sign right here, okay? All right, so let's do another one. Transition over here. Okay, so we have another triangle. We need to find the missing angle. We need to find angle U. So angle U right here, we'll put a little theta. Okay, so let's see which trigonometric function we have to use. Well, we know that the one across, this is going to be the hypotenuse. Okay, the one right next to the theta, that's going to be the adjacent, because that's what adjacent means, next to, and this one across is going to be the opposite. So we're using the hypotenuse and we're using the adjacent. So if you think, all right, so katoa, which one uses the adjacent and the hypotenuse? Adjacent hypotenuse, that is cosine. So we should just set this up like normal. The cosine of an angle, theta, equals the adjacent. Which one's the adjacent to this one? The one next to it is 2 over 5. So we have 2 over 5. Or if you don't like fractions, you can write cosine of theta equals 0.4. And remember, we have to get this by itself, but we can't divide both sides by a word, right? We can't divide both sides by the word multiply. We have to do the opposite. And in this case, the opposite of cosigning something is inverse cosigning it. Okay, and when you inverse cosine it, these switch. So it's the inverse cosine of 2 over 5, which equals theta, or the inverse cosine of 0.4 equals theta. So now we can just put this into our calculator, and when we do that, we get that our theta equals 66.4 degrees. So this angle is 66.4 degrees. Okay, and this little symbol right there means degrees. Okay, and once again, if you have a calculator that has this little symbol up here, then you can just put that straight in, but some won't. So you can either put in the calculator like this, or instead of cosine inverse, right, you can also arc cosine of 2 over 5. These mean the same exact thing. It's just another way to write the inverse of cosine. Like I said, I would make it INV cos, because then it makes more sense, but I don't make the rules. All right, last one. let's find the measure of angle E. So the angle E is down here, theta. Let's go ahead and label our sides. The one across, this is the hypotenuse. The one right next to this one, this is the adjacent. And then the one across from that angle is the opposite. Okay, so we're using the adjacent side and we're using the opposite side, right? The hypotenuse side does not give us any info. So A and O, that is the tangent, right? SOHCAHTOA TOA. So we do the tangent of the angle, theta, equals the opposite over adjacent. The opposite of the theta is 5 over 5. Or you can write it tangent of theta equals 1. And now we can't divide both sides by the word tangent. We have to do this inverse. The inverse of the tangent, these switch spots. 5 over 5 equals theta. Theta's by itself. Dope. Both of these will give us the answer. We put this in the calculator, and when you do that, we get that becomes 45 degrees. So our theta is 45 degrees. And once again, to put this in the calculator, you can either put it as this if you have a calculator that has this. Some won't. If you're putting it into the Google calculator, you might want to put it in like arc. 10 of 5 over 5. Now we have the basics of trigonometry. Thank you for listening to this super exciting lesson. Have a great day.